Today's session is going to be very interesting and it's very much practical in nature. In the sense, these kind of concepts, you do not really find it in academics. These are very much followed in the industry. The same thing, like a similar session to this one is data cleaning. Academically, you may not find a lot of topics or papers around data cleaning, but data cleaning is one of the most important aspect in data science. Similarly, model selection cross validation. Validation is one of the important phases when it comes to machine learning model building. Do you remember those phases? What is the first phase? You start with the business objective. Have you realized how much important the business background, knowing what business we are handling, knowing what is the objective? Have you already realized it? Don't you think this is one of the important aspect in practical life scenarios? We generally don't talk about it in academics, but this is very important, isn't it? Then we go to data exploration, data collection, basic summaries, etc. Then we go to data validation, preparing data for analysis. Then we build the model. Depending on the type of the data, depending on the objective, sometimes you may have to build a model that is regression. Sometimes you may have to build a model that is logistic regression. Sometimes you want to do customer segmentation. In that scenario, which model would you like to build? If you want to build a marketing strategy using segmentation, then you would go for decision trees. Depending on like selecting the right model, is it like based on the data or is based on the objective? There are multiple factors that we use for selecting the right model, isn't it? Depending on what is our objective, we select the right model and then we do variable selection, etc., etc. Based on all of that, we have built the model. Now I'm going to talk about validating the model. I'm going to show you, already we have discussed some of the basic validation techniques or some of the basic validation measures or metrics. What are they? When you are validating a regression model, you're using R square. When you are validating a classification type of models, what are the models that you're using? What are the techniques that you're using? You're creating confusion matrix, and then from there you're deriving the accuracy. Apart from this, there are several other methodologies as well, metrics. We are going to discuss them now. Now, model deployment, in this course, we are not going to get into model deployment because that requires a little bit of DevOps knowledge. So what is this DevOps team? They take our model and depending on the final platform where this model should be deployed, that expert will come into the picture. And there are several other factors into this. Let us suppose your model has to make 30 predictions per 1 minute versus 30 lakh predictions or 3 million predictions for 1 minute. Depending on that, you may have to change the server, etc., etc. Basically, this whole deployment is a different field altogether. Generally, that is taken care by DevOps team. As a data scientist, you are very much involved in these 4 steps. Usually, this is taken care by our higher management. They will tell us what is the objective, etc., etc. It's not in your hand. You don't decide what need to be done. It is given to you. But as a data scientist, you are very much involved here, very much involved here, very much here, very much here. Sometimes this is taken care by a separate team, but we must know validating the model as well. But most of the times, deployment is taken care by DevOps team. In some cases, maybe you're getting into this as well. But mostly right now, the situation of the data scientist is somewhat, most of the profiles are related to phase 2, phase 3, phase 4, phase 5. Let us talk about validating the model validation metrics. Already we have seen for regression, we have used R square. There are several other measures. Apart from R square, you will see some other measures being used, but everything is connected to error only, error or accuracy. If you take error, what is error? You have Y actual value and at error at one point, if you take, please go on mute. If you take error at one point, okay, you take the Y actual value minus Y predicted value. That is error at one point. Now, from here, you can derive a little bit of other metric, which is similar to this. If you take sum of squares of error, what will be the formula? So this will be the error, Y actual minus Y predicted at one point I. Predictions are generally denoted by this Y hat. Take the square of them, take the summation. Sum of squares of error, I running from 1 to n rows. Tell me, for a good model, if you're comparing sum of squares of error, that should be a higher value or a lower value. When you're comparing two models, M1 versus M2, which model would you pick? The model that has lesser sum of squares of error. So can I use sum of squares of error as one of the model validation metric for regression cases? Yeah, we can use it. That is also done in some cases. But anyway, R square somewhat connected to sum of squares of error. Then there is something called MAD, mean absolute deviation. So this is the deviation at or the error at one point. But sometimes the error is positive, sometimes the error is negative. That's why we take the absolute error and take the average of it. What do you mean by average? Take the sum divided by count. If you take sum divided by count, this is deviation, absolute deviation. Take the mean of that. So this is known as mean absolute deviation. It is known as MAD. So when you are comparing model M1 versus M2, what should be the MAD value? A higher value or a lower value? Mean absolute deviation.
Lower.
It should be lower value. I'll tell you, like there are, see, from here you can derive so many other measures. I'll tell you about one more measure. Then you can see, like, based on the need, next time when you see any new measure, just see that it is trying to reflect the error. There is one measure that is frequently used as an alternative to R square. What is that? You take the Y actual value, Y predicted value, Y actual, Y predicted, take the absolute value of it, take the absolute value of Y actual, Y predicted. This is at 1 point. Take the average, that is 1 to n. Okay. Now, let us suppose model M1 was predicting some kind of sales, but the sales was in millions. Okay. Model M2 is predicting some kind of users. Now, users are in thousands. Now, imagine mean absolute deviation here is actually 10,000. The value is in millions. The original sales value is in millions. When you compare to a million, a deviation of 10,000, is it a big deal? When you compare to a million, a deviation of 5,000, is it a big deal? Not really, isn't it? 5,000, when you are comparing, let's say 1 million is the actual value, but you predicted 1 million, 5,000, that is not a very big difference, isn't it? Not a great difference. But here, 5,000 or let's say 4,000, the users are in thousands only. Your difference is 4,000. Tell me, 5,000 is that bigger or 4,000 is bigger in this scenario, in this particular specific case? Tell me.
4,000 is
4,000 is bigger, isn't it? You have to see the context, because here thousands are the actual target variable. When compared to thousands, the deviation of 1,000 is too much, 400 times bigger. But here, compared to a million, a deviation of 5,000 is not much. That's why sometimes this MAD value, especially when you're comparing two different scales, MAD doesn't give you the real picture. If you directly see MAD, mean absolute deviation, 5,000 versus 4,000, anybody would say 5,000 is higher. But is that true here in this scenario? It's not. So that's why what do we do? Let us not take directly MAD. Instead of taking the deviation, absolute deviation, what you do is take the percentage of deviation. Divide 5,000 by million. Okay. Then you will get a very small percentage. Yes or no? You'll get 0.5%. Divide 4,000 by 1,000. Then what will you get? 400%. Here 0.5% is the difference, 400% is the difference. Divided by Y actual value. This is known as mean absolute percentage error. This is one of the closest alternative to R square. If you feel R square is difficult to explain, you can use something called mean absolute percentage error. Have you understood the concept of mean absolute percentage error? Instead of taking the actual error, you're taking percentage of error. How do you take the percentage? By dividing it with the Y actual value. Now, when you're comparing two models, model M1 has a mean absolute percentage error of 10%. Model M2 has a mean absolute percentage error of 3%. Which model is preferred? M1 has mean absolute percentage of 10%. M2 has a mean absolute percentage error MAP of 3%. Which one would you prefer?
M2.
M2. If the actual value is 100, then what is the range of M1? What is the range of M1? What is the predicted value range? If actual value is 100 with a 10% MAP, what does that mean? 10% is mean absolute percentage error given by this model. If the actual value is 100, M1 is likely to give a prediction somewhere in the range of
90.
90 to 110, isn't it? Because it is plus or minus 10%. Whereas M2, if 100 is the actual value, it is likely to give the predicted value in the range of
97 to 103.
97 to 103.
103. Tell me which model is doing a better job in giving a prediction which is very near to actual?
M2.
M2.
So mean absolute percentage error, have you understood this concept? MAPE value, mean absolute percentage error, has to be very less value, as close to 0 as possible. Do you agree with that point? So that is one more alternative. If you feel your client doesn't understand the concept of R square, they feel it is too difficult to analyze, then what is the quickest alternative that you can give? Mean absolute percentage error. So error at 1 point, that all of us understand. Sum of squares of error. Take error, take the square, take the summation of all of those. Sum of squares of error has to be less. This can be used. Mean absolute deviation, this has to be less, but it has a problem. It is scale dependent. Mean absolute percentage error, this is one of the best alternative. You can also use mean squared error, root mean square error. Sometimes you see these kind of terms popping up. But what I would say is the most widely used validation metrics in regression are R square. If somebody asks you, give me how do you validate regression model, you first refer to R square. If they ask you, give me an alternative, what would you give? Will you be able to recollect any of these? immediately you give mean absolute percentage error MAP. Will you be able to explain this to a layman? What exactly this means with a kind of example, simple examples? In machine learning, it's not only about understanding, it's also about explaining it in simple terms. Okay. So try to understand all this and try to come up with some examples. And you can also give sum of squares of error as another alternative, or root mean square error, etc. That is for regression, but our favorite is classification, because most of the real life scenarios are connected to classification. You agree with that, isn't it? Almost all the projects are connected to classification. Let us quickly go to classification. There are nearly 40 validation metrics in classification. It's impossible to cover all those, but we will try to cover almost all the important ones. Imagine you have a model that is 99.999% accurate. Are you going to approve that model? Are you going to deploy that model? Is that a good model to you? If you have a model that is 99.999% accurate, is that a good model?
Yes, sir.
Maybe.
There is one small problem. What is it? Sometimes if the model is showing you this much high accuracy, immediately something should pop up in your mind. It may be a case of
Overfitting.
Data.
overfitting, isn't it? You remember that? What is overfitting? Try to recollect it. What is overfitting?
Accuracy showing
Overfitting.
high for
On the trained data, the
Trained data
accuracy is very high. And on
Test
the
data.
test data, if the
very low.
accuracy is significantly lower, then we will not approve this model, isn't it? Imagine for a scenario, you have train accuracy is 99.999% accurate. Test accuracy is also 99.999% accurate. Are you going to approve this model?
No,
Now,
sir.
why?
Yes.
What's the problem? Train accuracy on the train data 99.999%, on the test data 99.999%. It is working well on the train data. It is, what is our rule? Your model should have highest accuracy on the train data and simultaneously matching accuracy on the test data. Is it a good model? Of course, it's a good model. We're going to approve such models, isn't it? Highest accuracy on train data, matching accuracy on test data. Let us see what is this model. This is actually a model. And what is this model doing? This model is trying to predict whether there is a bomb in the car or not. Basically, this is a platform. What this platform has, it has all these sensors. These sensors will try to take some information from this car. The car has to come and stand on that platform. Automatically, it will take all the information. It will detect whether there are any metallic objects, etc., etc. And then this information will be sent to an ML model. This ML model will make a prediction whether there is a bomb in this car or whether there is no bomb in this car. This model has to make that prediction whether there is a bomb or no bomb. That's what it has to predict. Now, these kind of models have to be highly accurate. Yes or no? They have to be as much accurate as possible. Imagine a scenario. We have applied this model on 1 lakh cars. All of you try to understand this. We applied this model on 1 lakh cars. You know what happened? We already know that out of 1 lakh cars, one car has a bomb. We got the information from some intelligence department that there is a car that is coming to this function which has a bomb in it. So 1 lakh cars have attended this, or on this highway, 1 lakh cars are going. One of them have the bomb. 99,999 cars have no bomb. They belong to class 0. One car has a bomb. They belong to class 1. Is this scenario clear until here? The story? What is the story? We have a model that predicts whether there's a bomb in the car or not. Now I'm going to test that model on these 1 lakh cars. Okay. Now this is the actual value. This is the result after applying the model. What did our model predict? When I took this model, when I applied it on all the cars, I made all the cars go through this model. The model has predicted that all the 1 lakh cars are predicted as class 0. What do you mean by class 0 here? The model is predicting all the 1 lakh cars are having no bomb, safe. Right? Yes. Shall we find out the accuracy of this model now? Shall we do that? How do you find out the accuracy? First, you have to take the y actual values. 1, 2, 3, and so on. These are all zeros. This is 1. Is y actual column clear to you, all of you?
Yes, sir.
99,999 cars have no bomb. One car has bomb. Now, what are the y predicted values? Tell me. For the first car, when it goes, what will be the predicted value?
0.
0. Second car?
0.
Third, fourth, fifth. For all the 1 lakh cars. What about this car? When this passes, what is our model predicting this?
0.
This is also predicted as 0. What did our model predict? All the 1 lakh cars are predicted as class 0. Shall we create the confusion matrix now? Y predicted, Y actual. Are you absolutely clear on this, everybody? Yeah? Yes. Y actual values, there is only one. Y predictions, all are zeros. Shall we create the confusion matrix for this? You have 0. These are the Y actual values. You have 1. So overall, how many zeros are there in the y-axial? Total, how many zeros are there? The cars without the bomb, how many are there total? If I look at this row total, how much that would be?
99,999.
Make sense? How many cars are there with the bomb?
1.
Overall, one. Now, out of these 99,999, how many are predicted as no bomb? 0 predicted as 0. How many times did that happen? 0 has been predicted as 0.
99,999.
Okay, that's good. 0 predicted as 0. Model is doing a great job. Wonderful. No problem with that. How about this one? Model has no bomb, but it has been predicted as bomb. 0 predicted as 1. Has it ever happened? 0
No.
predicted as 1.
No.
No.
What will be the count here?
0.
0.
0.
1 predicted as 0. Has it ever happened? 1
Yes.
has been predicted
Yes.
as
Yes.
0. How many instances?
1. 1.
1.
1 predicted as 1. Has it ever happened?
No.
No.
0 here again. So this is 99,999. This is 0, 0. Now, can you tell me the formula for accuracy in the numerator? What should I write? Numerator should be accuracy. How do you find the accuracy? What is the formula?
No. Y-axial minus
99,999 plus
1.
Array, this is predicting 0 as 0, predicting 1 as 1, right?
Hmm.
What are the right accuracies, right? Predicting 0 as 0, predicting 1 as 1. That will be in the numerator.
0.
Yes. Are you with me, everyone?
Yes.
0 as 0, 1 as 1. That will be in the numerator. What will be in the denominator? Overall number of rows. How many overall number of rows are there?
1 lakh.
1
1 lakh are there.
1 lakh.
So this is the numerator. This is denominator. Tell me what is the accuracy here? 99,999 divided by 1 lakh, which is 99.999% accuracy. So this model is 99.999% accurate. Tell me one thing. Why did we build this model? What was the purpose of the model? Tell me what's the purpose of this model?
To detect the bomb.
To detect the bomb. And the model accuracy is 99.999%. Did the model really detect the bomb?
No.
Did
No.
it solve our purpose?
No, sir.
Finally, out of 1 lakh cars, 1 car has the bomb. Has the model predicted it accurately? What really matters to me, when there is no bomb, do I really care about this class?
No.
Do I really worry about this class?
No.
Which is the class that I am really worried about? Which is the class that I want very high accuracy? Which
One.
class? Do you think class 0 is same as class 1 here, or they are highly, highly different?
Different.
One of them is very much important for me, other one is not at all important for me. Do you agree with that point?
Yes.
Yes, sir.
Yes or no?
Yes, sir.
In fact, class 0 has 99,999 records. Class 1 has only 1 record. Do you think these two classes are balanced, or there is some class imbalance in this data?
Imbalance.
There is definitely class imbalance. What do you mean by class imbalance? Imbalance means there are few records that are very much dominating in one class. In the other class, there are very, very few records. When there is class imbalance, looking at the overall accuracy doesn't give us the right picture. Do you agree with that? When you have class imbalance, giving equal importance to both of them is not the right way to go. Are you convinced with that? When you have class imbalance, overall accuracy doesn't give you the right picture. What is the real performance of the model? That you will not get that by looking at the overall accuracy. There has to be some other measure. Yes or no? Overall accuracy gives you equal importance. It gives equal importance to class 0, equal importance to class 1. You don't want that, isn't it? Are you with me, everyone? Have you seen the contradiction here? The problem is, if you look at the overall accuracy, the accuracy looks pretty good, but the model is not really useful. When there is class imbalance, do not look at the overall accuracy. Make a side note here. Overall accuracy fails. When does it fail? When there is class imbalance. Then what is the alternative? Look at the class-wise accuracy. What do you need to look at? You need to look at the class-wise accuracy. Let us look at the first class. This class. How many records are there overall in this class? Overall number of records in the denominator I'm talking about. Overall number of records in this class. How many zeros are there totally?
1.
1.
Zeros. Number of zeros.
Sorry. No.
99,999 in this class. I'm talking about class 0. There are these many records. Out of them, how many are accurate predictions?
All 99,999.
I'm talking about still this one only. 99,999 cars have no bomb. Out of them, how many are accurately predicted that, yes, there is no bomb in this? How many times we did that prediction accurately? These are accurate predictions, isn't it? All of them we have predicted accurately. So what is the accuracy of this particular class when there is no bomb? What was our model accuracy?
1.
100%.
100%? 100%? Yes or no? Are you convinced
Yes,
with
sir.
this? All of you tell me, look at that formula. Is that right? What I have written here. All the cases are here and whatever are the right accurate predictions are here. Can I say accuracy of class 0 is 100%? Model has predicted class 0 with 100% accuracy. Tell me,
Yes.
are you convinced with that point?
Yes, yes.
Yes, sir.
Yes, sir.
Yeah. Now let us talk
Yeah.
about the accuracy of class 1. How many cars are there with the bomb? Tell me the denominator first. Overall
One.
cars with the bomb.
One.
One.
1. Let us talk about the numerator. How many times the model has accurately predicted? Out
Zero.
of all these cases,
Zero.
accurate predictions are 0.
Zero.
Tell me what is the
Zero.
accuracy percentage for
Zero.
class 1?
Zero.
0%. What is the accuracy of class 0? 100%. What is the accuracy of class 1? 0%. Tell me which class really matters to you?
One.
Which class are you interested in?
One.
Class 1.
One, sir.
What is the accuracy of that class which you are interested in? What is the
Zero.
accuracy the model is giving you for the class that you are
0%.
interested in?
Zero.
0%. Do you think you should go with overall accuracy of the model? Go ahead, deploy this model and assume that this model is going to perform super good, or it is mostly dominated by just one class? Think about it. Are you going to deploy this model?
No.
No, sir.
You would rather deploy a model which has only 80% accuracy, but it is taking care of class 1, the class that is important for you. Yes or no?
Yes.
In not
Yes.
every scenario, you should look at the overall accuracy. Overall accuracy is good only when there is balance between the classes. Balance. When there is class imbalance. What do you mean by class imbalance? Class 0 is not same as class 1 for me. Or for me, the importance is lying with one particular class. In that case, I have to go for class-wise accuracy. Accuracy of first class or the accuracy of class 0 is known as sensitivity. Accuracy of class 1 is known as specificity. These are the two new terms. However, their concept behind that is very easy. This is known as true positive. This is false negative. Tell me the formula for sensitivity then. What will be there in the denominator? The formula for sensitivity. Denominator will be overall number of records. True positives plus false negatives. What will be in the numerator? Numerator would be
True positive.
true positives. That is formula for sensitivity. Tell me the formula for specificity. Denominator will be false positive plus true negative. And what is the numerator? Right predictions are
True negative.
true negative.
Two negative.
You don't really need to worry about all these formulas, but in general, accuracy of class 0, accuracy of class 1, are you comfortable with both of them? Sensitivity, specificity, class 0, sensitivity, class 1, specificity. If I change their order, then class 1 would be sensitivity, class 2 would be specificity. The order doesn't matter. Individual class-wise accuracy is important in some cases. Do you agree with that point? Not every time you should look at overall accuracy. Let us look at one example. Think of this loan scenario, credit risk scenario. You're predicting whether the customer will be a defaulter, which means bad customer, versus non-defaulter, whether he's a good customer. You have bad customers, you have good customers. You're going to predict bad as bad customer. You're going to predict, your model is going to predict good as good customer. So there's a bad customer, model predicted him as bad, very good. Good customer, model predicted him as good, that is also very good. Now look at the scenarios where the model is making some error. Look at this error. Actual customer is bad, the model is predicting him as good. This is one type of error. Look at this, all of you. Actual customer is bad, but the model is predicting him as good. Now, actual customer is good. Sometimes the model is predicting him as bad. That is also a type of error, isn't it? Type 2 error. Okay. Actual customer is good, but the model is predicting him as bad. Now, tell me, which one is more dangerous? Bad customer predicted as good, is that dangerous? Or good customer predicted as bad, is that dangerous? Think about it, business scenario. Bad customer applied for a loan, and you model predicted him as good. What will you do? What will be your action?
It is more dangerous.
A bad customer applied for a loan. Your model predicted him as good. What will you do? He applied for a loan of 10 lakhs. What will you do? You will go ahead and approve that.
Approve.
But the good innocent customer came to you. Model predicted him as bad. What are you going to do?
Bad.
Good guy.
Decline.
You're going to decline.
Decline.
When you decline an application, are you going to make any loss? Is there any
No.
risk of money?
No.
No.
Only the profit you will lose. But what is the risk here?
Entire 10 lakhs.
The bad customer is approved.
Bad person is approved, you will lose 10 lakhs. Tell me, one mistake here, is it equal to one mistake here?
No.
No.
Sometimes you give very, very big loans. They are going to, is it fair to say one bad customer may eat out 100 good customers' profit in some cases?
Yes.
So in this
Yes.
case, tell me which one is very important for you? Sensitivity, that means class 0 accuracy, or specificity, class 1 accuracy, or overall accuracy. What are you going to track when you are building this model?
Sensitivity.
Sensitivity.
Class 0 accuracy, which is sensitivity in this case. Are you with me, everyone? Is it true that in every scenario, all the problems in this world, sensitivity is the only important metrics, or can there be some cases where specificity is important?
Specificity can be important.
It depends on the problem statement. Do you agree with that? We have
Yes.
to see the problem statement, which is the class that is important for us from the business point of view, and we'll be focusing on that, isn't it? Let us think of a scenario where you are building a model that is predicting whether a particular medicine is good or poisonous. Medicine is good and you're predicting it as good. Very good. Medicine is poisonous, you're predicting it as poisonous. That is also very good. Medicine is actually good, but the model is predicting it as poisonous. This is one type of error. Medicine is poisonous, your model is predicting him as good. That is another type of error. Okay. Now tell me which one is dangerous here. Let's say you made one mistake here. Good medicine has been predicted as poisonous. What will be your action after this?
Not take the medicine.
You will throw away that medicine. Poisonous medicine has been predicted as good. What will be the action after this?
We'll take the medicine.
So tell me one mistake here. Is it equal to one mistake here?
No.
No.
No, not at all. What is the loss here? Tell me. What is the loss? What is the risk? What is the loss?
No loss.
A little bit of money, monetary loss. What will be the loss here?
Life.
Loss of life. Obviously, one mistake here is not same as one mistake here. In this case, when you are building this model, are you going to look at sensitivity? Are you going to look at specificity? Or are you going to look at overall accuracy? Is that important for you? Which one is important?
Specificity.
Specificity. Especially what I'm seeing is, especially most of the students, somehow they are kind of very much connected, addicted to this accuracy. They feel very bad that my model is not giving good accuracy and all that. But does the overall accuracy matter? Especially when there is class imbalance? Does it really matter? It doesn't matter, isn't it? Accuracy of that specific class, that only matters. Other class, you don't worry about that. But the calculation of sensitivity, specificity, though these terms are looking very complex, but the calculations are pretty simple. Yes or no? Let me give you confusion matrix once again. Let me ask you, let's say this is class 0, this is class 1, this is class 0, this is class 1, this is A, B, C, D. Tell me the calculation of sensitivity. Sensitivity calculation.
A divided by A plus.
Very good. Tell me the calculation of specificity.
D divided by C plus.
These are right predictions, right prediction. I'm assuming that you found this easy to understand, isn't it? Though this is a lot of terminology, but overall everything is derived from confusion matrix only. Have you now understood why accuracy is not only the measure that we should be looking at? We should go beyond accuracy to class-wise accuracy. Are you convinced with that point?
Yes.
Yeah. So let us build a model and then calculate accuracy, calculate sensitivity, calculate specificity. Open the code file, share the link with me to the code file. We'll open the code file here. Yep, here is the code file. Quickly open the code file and then try to build a model. Model building anyway, all of us are comfortable since it is just a logistic regression model. All right, import the packages, import the data set. Basically, this particular definition, it's a formula creation function. What it does is it'll try to generate y tilde x1 plus x2 plus x3 and so on. Either you can use this function or you can directly write the variables also. This is just an additional function for you to use it. Okay, either you can use it or you can ignore it. Basically, if you have so many variables, writing all of them sometimes becomes tedious. If you use this function, it will automatically generate this model formula y tilde x1 plus x2 plus x3. You just need to mention the x variables. You just need to mention the y variable. This formula will be generated. Okay. Now build the model. Tell me for this model, what is your accuracy first? What is your sensitivity? What is your specificity? You have class 0, class 1, class 0, class 1.
Sensitivity is 0.9. So
Overall accuracy, how much have you got? Overall accuracy first.
93.
93% is the accuracy. Sensitivity, class 0 accuracy is what?
99.
99%. Specificity, how much?
14.9.
Which is like 14%. Okay. Now check this out. What is the target variable here? Target variable is serious delinquency. It takes values serious delinquency 0, serious delinquency 1. Serious delinquency 0 means what? Good customer or bad customer? Serious delinquency 0. That means he is not seriously delinquent, which means what? 0 means
Good.
good customer. Are you with me, everyone? Good customer. Somebody is not seriously delinquent. Means he's a good customer, right? He's paying back everything. Serious delinquency 1 means he is actually seriously delinquent. That means he's a bad customer. Okay. Now this is good customer. This is bad customer. Now in this scenario, which one is very important for you? Is it overall accuracy that you will be worried about that? Or predicting good customers accurately? Is sensitivity? Are you worried about that? Or predicting bad customers, capturing bad customers accurately? Are you worried about that? Specificity. Which one are you worried about mostly?
Specificity.
Predict if a customer is bad, no matter what happens, we have to capture him. What will be the loss? Let's say bad customer is predicted as good customer. That is one type of error here. Good customer is predicted as bad customer. That is also one type of error. One mistake, how much will it cost? Good customer has been predicted as bad. What will you do? What will be your action after that? A good guy has been predicted as a bad guy. What will be your action?
Decline the loan.
Decline the loan. What will be your loss in that case?
0.
Maybe some kind of opportunity loss, some kind of profit and all that, but no risk, isn't it? Like you're not putting any money on the table. Yes, you will lose a profit, but that is not really considered as a loss, isn't it? Without playing the game, you cannot say I have lost. Yes or no? But what about the loss here? If you make one mistake here, bad customer has been predicted as good customer. What will be the loss? Is there anything at risk here comparatively?
Entire loan amount will be.
Entire loan amount will be wiped out. Sometimes 80% will be wiped out. They'll just pay 1 or 2 EMIs. Then they'll vanish, isn't it? We will not be able to trace them. Tell me, in this case, is it overall accuracy? Or will you be happy by looking at 93% overall accuracy? My model is so great. Or sensitivity 99%, will you be super happy? Or specificity 14%, will you be sad? Tell me, when you are building this model, what will be your action? Tell me which one is very important for us.
Specificity.
Specificity. But are we getting a good number here?
No.
We are not.
No.
So that's a problem here, isn't it? Look at this scenario where the model overall accuracy looks super good, but in reality, is it solving our purpose?
No.
Not really, isn't it? That is why we need to be careful with this metric accuracy. In real life scenarios, nobody really cares about accuracy. I want you to give as less preference to accuracy as possible from here on. Are you convinced with that, all of you? You must focus only on the class that really, which is very important. Okay. Now I'm going to tell you how to improve the specificity from 14% to maybe like 25%, maybe like 40%, maybe 60%, as much as possible. How do you increase it? What are some of the methodologies that are used in the industry that will increase this specificity? Even if the accuracy decreases, specificity increases. Are you happy with that? Think about it. Your overall accuracy looks 80%, but specificity is around 40%. Will you be happy with that model? Think of a scenario, accuracy 93%, specificity 15% versus accuracy is 80%, specificity is 40%. Which one would you go with in this scenario?
Second one.
Yes. For you, what really matters is specificity. That's what context will bring us, isn't it? Any novice machine learning guy would directly go for this one without any background. But what we must focus on is the class that really matters to us. So what you can do is sometimes, especially when you're working with logistic regression, logistic regression output is given as some kind of a number between 0 and 1. Logistic regression output, you will get a number between 0 and 1. Automatically at 0.5, some kind of threshold is created. Anything below 0.5 is considered as class 0. Greater than or equal to 0.5 is considered as class 1. Automatically, the Python tool does that. But we can override it. We can change that threshold. For example, this is the car with the bomb. This is the car with the no bomb. Until now, what are we doing? If the probability is more than 0.5, we will say there is a bomb in it. If the probability is less than 0.5, we will say there is no bomb in it. Okay. That's what automatically by default Python does it. Think of a scenario, you got the probability to be 0.35. Tell me honestly, there's a 35% probability that there is a chance for the bomb. Would you say that if you are inspecting that car You got 35% probability. Are you going to say that 35% is less than 50%? Let that car go. Or would you say that getting this probability itself is very rare? I don't want to take any chance. Even though it is less than 0.5%, it is less than 50%, I would still like to verify that car. What will be your action? Tell me. Would you like to classify this car as bomb one or no bomb one?
Bomb
Which
one.
class?
Bomb one.
Since this is very important for us, since this is very rare for us, even though that is less than 0.5, still I would like to call that as class 1 only. That is why if class 1 is very important for you, put the threshold at a very lower value, maybe at 0.2. That means even if you get the probability as 0.25, what would you say? Ideally, if the probability is 0.25, ideally you call that as class 0. But here it is a special case scenario. You're going to call even 0.25 as, you're going to classify 0.25 as
Plus one.
class 1. Is that justified?
Yes.
Yeah. Are you convinced with that? What is the justification? Because class 1 is very important for me. Class 1 is very rare. Even though there is a lesser probability, I would like to call everything above 0.2 as class 1. Everything below 0.2 as class 0. What will be the effect of it? Unnecessarily, you will be calling a lot of cars without the bomb as bombed ones. But is that okay?
Okay.
Yeah. Because you are going to maximize the finding of the bombed car. That is why you can reduce the threshold. What if you want to do the opposite of it? Let's say, what if this class is very important for you? Class 0 is important. In that case, where will you keep the threshold? That means even if it is 0.6 or 0.7, even if it is 0.8, you would say call that as class 0 only. Does that make sense? So you can play with the threshold. If class 1 is very important for you, keep a low threshold, call everything, most of them as class 1s, so that you will not miss that class 1. By reducing the threshold, can you really capture with more probability the cars with the bomb? Similarly, if class 0 is very important for you, put a threshold at a very higher value, then you'll be able to capture class 0 effectively. So by changing the threshold, you can change the sensitivity and specificity values. Do you agree with that? By changing the threshold, you will change the accuracy, sensitivity, specificity, because we are changing the definition of class 0, class 1 prediction. So change the threshold values to the previous example, then you will observe the accuracy, sensitivity, specificity, they are changing. So try a low threshold value. What will happen if you try a low threshold value? Which probability will increase? If you try a low threshold value, which probability will increase?
Class one.
Probability of class 1. If you try a very high threshold value, which probability will increase?
Class 0.
Class 0 probability. So try a low threshold value. Tell me what is the accuracy, sensitivity, and specificity. The updated accuracy 92%. Earlier, what was the accuracy previously? I think from 93, you now got 92. A little bit dip in the accuracy, but are we really worried about it?
No.
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 And sensitivity previously, how much was the sensitivity previously? 99. From 99, now you got it down to
96.
96. There is a 3% dip in that. Are you worried about that?
No.
Because you don't care about class 0, which is good customer. From previously, 15% was the specificity. Now it is
35.
35%. Is that a good lift? Previously,
Yes.
out of 100, how many are you capturing as bad customers? Out of 100 bad customers, if they apply, how many bad loans you are giving? Only 15% you captured. 85% bad loans you are giving. Now, how much percent bad loans will you be giving?
35.
You're capturing 35, which
Okay.
means you're giving around 65% bad loans. Still bad, but this is much better, isn't it?
Yes, sir.
Are you with me, everyone? Not every time just accuracy matters. It's the class that you're really looking at that really matters. Changing the threshold is one of the methodologies for increasing or decreasing the sensitivity or specificity. Are you following the whole story, everyone? Are you convinced? Why am I focusing only one class, first of all?
Yes.
Yeah. Do you also anticipate class imbalance in your problem statement, all of you? The project that you're dealing, is there class imbalance or class 0 is same as class 1 in your case? Think of it. Is there a kind of class imbalance in your project? Do you think exactly 50% are bad customers, 50% are good customers in your case, or a lot of them are good customers, few of them are bad customers in your project? Usually what happens in credit risk is a lot of them will be good customers. A lot of customers will pay back.
Yes.
Very few will be bad customers. Yes or no? Even in our friend circle, if we see, more than 90% of our friends will pay back the loan that they have taken. Very, very rare cases. People do not pay back the loan. That also their compulsion rather than a choice, isn't it?
Yes, sir.
Now, sensitivity, specificity are the two new terms that I have introduced, but I don't think you have to worry about these terms a lot. The concept behind them is pretty simple. Yes or no? Will you be able to explain sensitivity, specificity? In which scenario I would go for sensitivity, specificity? Okay. Now, there are several other terms that are used in some companies. Sensitivity, specificity is the terminology that is used. The same thing, there are several ways of calling this. There is another concept called precision and recall. Unnecessarily new terms are introduced, but the concept behind them is very simple. Do not really worry about these terms and all that. Okay. But the concept behind that is very simple. Whatever we called as sensitivity, it is known as recall of class 0. Whatever we called as specificity, that is known as recall of class 1. Recall of class 0 is sensitivity. Recall of class 1 is specificity. Now we are looking at from the actuals point of view. Look at this. Out of all, let's say 10,000 customers, how many of them are predicted accurately? Out of all 25,000 customers, how many of them are predicted accurately? We are looking at it from actual point of view. Sometimes you can look at it from predicted point of view. Let's say you have made predictions as, let's say, 9,800. Out of all the predictions that you made, how many of them are accurate? Look at this once again, the question. Out of all the predictions, 9,800 you predicted as positive. How many of them are accurate? That is known as precision. Tell me, what is the formula for precision? What will be the formula for precision? Let's say this is true positive, this is false positive. What will be the formula in that case? If you look at it from the column point of view, true positive by true positive plus false positive. Basically, you're looking at the accuracy earlier from the row point of view. You look at it from the column point of view. This is precision of class 0. What is precision of class 1?
True negative by false positive.
True negative by false negative plus true negative. You're looking at it from the column point of view, isn't it? So this is recall of class 0, recall of class 1, precision of class 0, precision of class 1. I think though these are several terms, but the concept behind them is very easy. Let us recap once again. If this is confusion matrix 0, 1, 0, 1, A, B, C, D, tell me sensitivity. What is the formula? Sensitivity.
A by A plus B.
A divided by A plus B.
Specificity. Always sensitivity is first class. Specificity.
B by C
B by
plus
C plus D.
D for Bombay.
D. D.
D.
for
D
for
Delhi.
Delhi.
D
Divided
by
by C plus D.
recall of class 0. Recall of class
A
0,
divided by A plus B.
Divided by A plus
which
B.
is equivalent to sensitivity.
Sensitivity.
Recall of class 1.
D divided by C.
Divided by C plus D.
B plus D.
Yes, recall of class 1. Same as specificity.
Specificity.
Precision of class 0.
A by
A
A plus C.
divided by
A
A plus C.
divided by A plus C.
Precision of class 1.
D divided by
D
D plus C.
divided by D plus D.
Though these are very, very different terms, all of the concept behind that is very simple. Do you agree with that? It's not that difficult to derive all these formulas. Yes or no? When all these things will come into the picture, in which scenario do you even consider sensitivity or specificity or recall or precision? What is the scenario that you come here, especially when there is in the data set, when there is
Class imbalance.
class imbalance? These are all the cases. When there's a class balance, that means 50% are this, 50% are this. What can you use? Almost 50-50 cases. You can use overall accuracy. When there is class imbalance, then only you come to individual classes. You focus on, if you want to focus on one class, then only all these things will come into the picture. I want you to note that these are not that difficult formulas. The terminology looks like this, but these are very easy formulas to understand. This comes into the picture when you want to focus on either class 0 or class 1. In fact, there is one more measure called F1 score. It is a combination of precision and recall. You take recall of the class, you take precision of the class, precision of class 0. This is precision of class 0. This is recall of class 0. You combine both of them, find the harmonic mean. There's a formula for harmonic mean. If you have ratios, you cannot directly find the mean. You have to find the harmonic mean. So there's a formula for it. So 2 divided by this whole thing, 1 by recall, 1 by precision, etc. That is known as F1 score. F1 score is another alternative for class-wise accuracy. You can find the F1 score of class 0. F1 score of class 1 and the class that you are focusing on, F1 score should be higher. Not everywhere it is used. Mostly sensitivity, specificity is the concept that is right now in the industry. At some places I have seen precision and recall is also used. Very rarely you will see F1 score. In some cases there are several other. So there is like F beta score, gain A, UC, gain A, KS, MAP, all these several validation measures are there, but all of them are trying to tell you one story only. How good is your overall accuracy, or how good is the model in predicting one class accurately? Whatever we discussed until now, are you comfortable in that, all of you?
Yes.
Yeah. Basically, the whole story, if you just summarize it, we are focusing on one class because both the classes are not equal for me. There is a class imbalance. So the next lab exercise is calculating precision recall F1 score for individual classes. Go ahead, execute that code. Actually, there are two ways to do it. We can write our own formulas because all of us are comfortable. A, B, C, D terminology, we are very much comfortable with it, right? Either you can write your own formula, or in sklearn.metrics, there is something called classification report that you can use, which will automatically give you the result. This is the one that I generally prefer because everything is in our hand. Or you can, once you're comfortable, you can also use ready-made function. No problem with that. Carry on. The whole discussion that we had until now, everything revolves around focusing on one class imbalance. That's the main point that I want to convey here. Not every time overall accuracy is given preference. In real life scenarios, one class, the one that is very important for me, that is the one that is focused on. Do you also agree in your project, apart from calculating accuracy, you must be calculating sensitivity, specificity, isn't it?